Lesson 3.3, we're going to compare linear and nonlinear functions. Usually these are going to be linear functions that we're comparing, but you could see some questions that ask about nonlinear, which just means that if they were graphed, they would not be a line. Some important terms and phrases to know are rate of change, which just means slope, and initial value, which just means y-intercept. Remember, we could also see these in the form of slope being represented by m, or rate of change is m, and y-intercept being represented by b, or initial value is called b. This is a model of a linear function. When it says model, it's just talking about an equation, and we're going to label the parts of this equation when we're dealing with functions. Remember, your y values are called output. Remember, in y equal mx plus b, that m, the number in front of x, is called the slope, and we also call this rate of change. In functions, your x values are called input. And then remember that in y equal mx plus b, that b is the number by itself, and in this case the number b is 4, which is the initial value, also called the y-intercept. In our example, we're given two functions, function a and function b. Which function has the greater rate of change? Which function has the greater initial value? Notice that they're represented in two different ways. Function a is given as a table of values. Function b is given as a graph. You can also see a function represented as an equation. And we're just going to start by finding the rates of change and comparing them. And then we'll find the initial values and compare those. Now for function a, we can find the rate of change by finding the change of y over the change of x. If we're told it's linear, then no matter what ordered pairs we choose, we should find the same slopes or rate of change. But I'll do a couple of these just to check. From 0 to 3, it goes up 3. From 0 to 2, it goes up 2. So going up 3 over 2 is 3 divided by 2, which we could leave as 3 halves, or I'm just going to go ahead and divide and get 1.5. Often we discuss rate of change with decimal values, but you can leave them as fractions. Either are fine. If I take these next two, I'd say 6 goes up 1.5 to get to 7.5, and 4 goes up 1 to get to 5. Well, that would be 1.5 over 1, which is different, but when we divide that, we also get 1.5. And you could also check from 3 to 6, these two middle order pairs, and you get it goes up 3. From 2 to 4, it goes up 2. And so the middle set of ordered pairs would also have a rate of change of 1.5. Looking at function b, to find the rate of change, we are just going to use rise over run. So I'm going to pick 2 points. Pick this point and this point, and I'm going to say it's going to rise. It goes up 1, and it runs 1 to the right. So it's got a slope or rate of change of 1. No matter what ordered pairs I pick off of that graph, I would get the same. If I picked this one, then I'd go up 2, right 2, and up 2, right 2 is still 1. So to answer the first question, which function has the greater rate of change? Well, 1.5 is greater, so function a has the greater rate of change. It's 1.5. The second question says which function has the greater initial value? That's your y-intercept. So sometimes in a table, such as function a, we're given the y-intercept. That's where x is 0. So let's look over here and see if the y-intercept where x equals 0 can be found. And we do have that right here. We have the ordered pair 0, 0. So when x is 0, y is 0. So b is 0. For function b, It's where the line crosses the y-axis. So it crosses right here at this point. B is 2. So which function has the greater initial value? Well, 2 is a greater value than 0, so it's function B. It's 2.